Now let us solve some important problems which has appeared in VTU exams. So here we have the question: solve d square plus 4d plus 3 into y equal to e raised to minus x, which has been given for 7 mark in December 19 VTU exams. So here, when you look at this example, here we have y as well as x term both. So it is non-homogeneous linear differential equation. Non-homogeneous linear differential equation. If non-homogeneous, we know solution, general solution y equal to CF plus PI. So solution is CF plus PI. Let us find out CF and PI separately. First find out CF. So for that refer LHS. Here we have d square plus 4d plus 3. So from that we can write auxiliary equation m square plus 4m plus 3 equal to 0. So which is a quadratic equation. Here we need to find m values. So let us think of factorization. So 3 can be written as 1 into 3. Now 1 into 3, 1 plus 3 is 4. So it can be factorized as m plus 1 into m plus 3 equal to 0. So here m plus 1 0, m plus 3 0. So m value minus 1, m equal to minus 3. So total m values are 2 m values, minus 1 and minus 3. So finally, if you look at both the values which are not equal, so if not equal, we write CF as C1 e raised to minus x plus C2 e raised to minus 3x. So this is the CF. So now half of the solution we got CF. Let us go for PI. So PI is in inverse differential operator method x by f of d. X by f of d. So x term e raised to minus x divided by d term. D term is d square plus 4d plus 3. So here we have e power ax divided by d term. So we know whenever we have e raised to ax and denominator is d, it can be written as e raised to ax by a. So replace denominator d by a. So it can be written as e raised to minus x divided by multiple of x is minus 1 here. So a is minus 1. Now replace d by minus 1. Minus 1 square 1. 4 into minus 1 minus 4 plus 3. So 3 plus 1 4 minus 4 0. So denominator becomes 0, means it is a indeterminate form. So in case of indeterminate form, we have the result whenever x by f of d takes the form x by 0. If it is 0, it can be written as x into x by f dash of d. F dash of d. So now, so it can be written as x into e raised to minus x divided by denominator f dash b d, means differentiate with respect to d. So d square 2d plus 4d differentiation 4. So like this we can write it. So now let us go further. So e raised to minus x divided by d term. Replace d by again minus 1. So minus 2 into minus 1 minus 2 plus 4. So now x e raised to minus x divided by denominator 4 minus 2 is 2. So this is how we get PI. So final solution from 1 y equal to CF plus PI. So CF here is C1 e raised to minus x plus C2 e raised to minus 3x plus PI x e raised to minus x by 2. So final answer y equal to this. Let us solve another problem. Question is solve d cube minus 1 into y equal to 3 cos 2x. So this has been given in exam for 6 marks in December 19 VTU second semester exams. So now, so here if you look at y, this example, it has y as well as x. So both it is having. So it is called, it is non-homogeneous linear differential equation. So in case of non-homogeneous, the general solution y equal to CF plus pi. So we know solution is CF plus pi. Take this as equation number 1. Now let us find out separately CF and pi. So first find out CF. For CF, refer LHS d cube minus 1. So auxiliary equation can be written as m cube minus 1. M cube minus 1 equal to 0. So now we have m values of from this. So cubic equation means it has 3 roots by fundamental theorem of algebra. So all roots you need to find out. So now if you look at this m cube minus a cube form, so 1 cube form, so it can be there is a algebraic result a cube minus b cube. So a cube minus b cube formula is a minus b into a square minus ab plus b square. So here a is m, b is 1, so it can be written as m minus 1 into m square minus m plus 1 equal to 0. So from this here we have product of two terms 0, factors 0. So m minus 1 0, m square minus m plus 1 equal to 0. So m minus 1 0 means m equal to 1. So one root we got. Now we need to factorize this one, quadratic equation. So we need to solve this one. Here 1 is there. So 1 into 1 1. But when you add it will be 2, which is not there here. So factorization is not possible for this problem. So then you can go for formula, Sridhar's formula. So here, so m can be written as, here a is 1, b minus 1, c 1. So m can be written as, m is minus b. So minus of minus 1 plus 1 minus b plus or minus square root of b square 1 minus 4 into 1 into 1, 4 divided by 2a. 2a is 2 into 1 2. So it can be written as 1 plus or minus root 1 minus 3 is 1 minus 4 is minus 3, square root minus 3 divided by 2. So square root of minus 3 can be written as 1 plus or minus I root 3 divided by 2, or 1 by 2 plus or minus I root 3 by 2. So now we have complex roots. So total m values are 1. One root is 1. Then remaining 2 complex roots 1 by 2 plus or minus I root 3 by 2. So total we have 3 roots, 1 real, 2 complex. So in case of real roots we write CF as C1 e raised to x plus complex roots. If you consider this term as alpha, this one as beta, so e raised to alpha x, e raised to 1 by 2x into bracket C1 cos beta x, beta is root 3 by 2x plus C2 sin root 3 by 2x. So this is how we can find out CF for the given problem. Now this is the half of the solution. Let us go for PI. So PI of this problem is, PI is x term divided by d term. So here x term is 3 cos 2x divided by d term is d cube minus 1. So now this has to be solved. But we know whenever we have cos ax divided by d square, so it can be written as cos ax by minus a square. So in case of cos x, denominator if it is d square, then only it can be replaced by minus a square. So here d cube is there. So one thing what we can do is, d cube can be written as d square into d minus 1. So now, so once you get d square, so it has to be replaced by minus a square. A is 2, a square is 4, so minus of 4. B square has to be replaced by minus 4. So it can be written as 3 cos 2x minus 4d minus 1, minus 4d minus 1. Or if you take minus common, it can be written as 3 cos 2x divided by minus 3 outside, so 4d plus 1. So here denominator is d term, but we know if denominator d square, then only cos has some result. So denominator has to be converted to d square term. For that, multiply by its conjugate. So 4d plus 1 can be multiplied as numerator and denominator multiply by 4d minus 1 divided by 4d minus 1. So now it can be written as minus 3 4d minus 1 into cos 2x divided by 4d minus 1, a plus b into a minus b, a square minus b square. So 16d square minus 1 square is 1. So now we have d square, numerator cos ax, so d square has to be replaced by minus 4. So now 16 into minus 4 minus 64 minus 1 minus 65. So minus 3 divided by minus 65. So minus 3 divided by minus 65 into bracket 4d differentiation of cos 2x. 4 into differentiation of cos 2x is minus 2 sin 2x minus 1 into cos 2x. So minus cos 2x. So finally it can be written as minus minus get cancels. So here we have common minus sign. So 3 by 65 into, so into bracket 8 sin 2x plus cos 2x, where we can take minus sign outside. So now we have CF as well as this is the PI. So final solution from 1 y equal to CF plus PI. So write another time CF PI together. Solve d cube plus 2d square plus d into y equal to x cube, which has been given in VTU model question paper for 7 mark. So let us solve it. So if you look at this example, it has y as well as x term. So it is called non-homogeneous linear differential equation. So in case of non-homogeneous, we know general solution y equal to CF plus PI. So take this as equation number 1. Let us find out separately CF and PI. For CF, refer LHS, which is d cube 2d square plus d. So auxiliary equation means replace d by m cube plus 2m square plus m equal to 0. So now here throughout m is common. M common if you take, m square plus 2m plus 1 we get. Now the product 0, it means m 0, this implies m 0, m square plus 2m plus 1 0. So now think of factorization. 1 can be factorized as 1 into 1. So here to add, it will be middle term, multiply, it is the last term. So it can be written as m plus 1 into m plus 1 equal to 0. So m values, m equal to minus 1, here also we get m equal to minus 1. So total m values are 0, minus 1, minus 1. So now if you look at the values, 0 is different and 2 equal roots. These are equal roots, this is different value. So CF can be written as C1 e raised to 0x plus 2 equal roots, C2 plus C3x e raised to minus x. So here e raised to 0 is 1, so it can be written as C1 plus C2 plus C3x into e raised to minus x. So this is CF. So now this is the half of the solution. Let us find out PI. So PI is, for the given problem, PI is x term divided by d term. So x term is x cube divided by d cube plus 2d square plus d. So here it has x cube polynomial in x divided by d term. So whenever we get polynomial in x divided by d term, so you apply normal division method. Normal division method means x cube inside the table, division table, and remaining in ascending powers of d, we can write d plus 2d square plus d cube. So now what you need to do is choose quotient such a way that it has to be, all the terms should be eliminated and remainder should be 0. So now to choose quotient, what you need to do is you just divide it. Divide the x cube divided by first term. So x cube divided by d means x cube by integration of x cube. 1 by d means integration of x cube, which is x raised to 4 by 4. So choose quotient x raised to 4 by 4. So multiply all terms to x raised to 4 by 4. So first d of x raised to 4 by 4, which is x cube, plus 2d square into that term. So 2d square into that term, 2d square into x raised to 4 by 4. So once you differentiate x cube 2 times 2 into 3x square. So total it will be 6x square. So 6x square. Next d cube of this, d cube of x raised to 4 by 4. So once you differentiate, it will be x cube. Another time differentiate 3x square. Another time 6x plus 6x. So now what you need to subtract? X cube minus x cube cancels. So minus 6x square minus 6x. So now, so this is again we need to choose quotient until we get remainder 0. So minus 6x square divided by d. Minus 6x square divided by d. It means integration of minus 6x square, which is minus 6x cube by 3. Integration of x square, x cube by 3. So which will be minus 2x cube. So now choose minus 2x cube. So now multiply all terms to that one. So when you multiply d into minus 2x cube minus 6x square, 2d square of minus 2x cube. So 2d square of minus 2x cube, it means minus 4 into d square of x cube. So d square of x cube is twice differentiate x cube. So 3x square 6x. So minus 4 into 6x, it is minus 24x. Minus 24x. So minus 24x. So now subtract minus of minus plus. So this will get cancelled. So 24x minus 6x. So it is 18x. So now 18x we got. So you need to choose another quotient term. So 18x divided by t. So 18x divided by d. It means 18 integration of x, which is 18x square by 2. It means 9x square. So here the term is 9x square. So plus 9x square. So d, differentiation of 9x square. d of 9x square is 18x. Next thing is multiply 2d square. 2d square of 9x square. So 18 into d square of x square. So d square of x square means differentiate twice. X square 2x, 2 into 18, 36. So plus 36. So now, so this is what we got. Minus subtract 18x minus 18x cancels. So minus 36. So now lastly choose another quotient. Minus 36 divided by d. Minus 36 divided by d, which means integration of minus 36, which is minus 36x. So minus 36x. So d, differentiation of minus 36x, minus 36. So minus of minus plus 36, 0. So now remainder is 0. So once remainder 0 means division process got completed. So once division process completed, the quotient so obtained, quotient, this part is called pi. So pi is x raised to 4 by 4 minus 2x cube plus 9x square minus 36x. So this is the phi. So final solution from equation 1, y equal to cf plus pi. So write sum of both is the final solution. Now let us solve another problem. Solve d cube plus 8 into y equal to x raised to 4 plus 2x plus 1. So which has been given in VTU model question paper for second semester students. So now if you look at this problem, it has y as well as x. So it is called, it is a non-homogeneous linear differential equation. So in case of non-homogeneous, solution y equal to cf plus pi. So let us find out cf and pi separately. First find out cf. So refer LHS. We have dq plus 8. So auxiliary equation can be written as m cube plus 8 equal to 0, but m cube it can be written as m cube plus 8 can be written as 2 cube. So it is of the form a cube plus b cube. So anyhow we need to solve it. Let us apply this result, algebraic result, a cube plus b cube. So a cube plus b cube is a plus b into a square minus ab plus b square. So now here a is m, b is 2, so it can be written as m plus 2 into bracket m square minus 2m plus 4 equal to 0. So m plus product 0 means m plus 2 0, m square minus 2m plus 4 0. So now here m plus 2 0 means m equal to minus 2, 1 root we got. So here quadratic equation, solve this one. 4 if you factorize, 4 can be written as 2 into 2, but when you add both it will not be minus 2, so factorization is not possible. So go for Sridhar's formula, a1 b minus 2 c 4. So let us apply Sridhar's formula, m equal to minus b minus of minus 2 plus 2 plus or minus square root of b square 4 minus 4 ac, 4 into 1 into 4 16 divided by 2a, so 2 into 1. So now 2 plus or minus square root of minus 12 divided by 2. So it can be written as 2 plus or minus, so square root of minus 1 is I, square root of 12 can be written as 2 root 3 divided by 2. So total finally if you divide it, 2 by 2 is 1 plus or minus I root 3. So these are the complex roots, alpha 1 beta root 3. We have roots like this, m equal to minus 2 and complex root 1 plus or minus I root 3. So here let us write CF. So complementary function CF, one real root CF c1 e raised to minus 2x plus two pair of conjugate complex roots. So e raised to alpha x, e raised to 1x into bracket c1 cos root 3x plus c2 sin root 3x. So total this is the final CF. Now let us find out PI. So PI is here in this case PI equal to x term divided by d term. So x term is x raised to 4 plus 2x plus 1 divided by d term is d cube plus 8. So now this is a polynomial in x divided by d term. So polynomial in x can be solved by normal division method. So x raised to 4 plus 2x plus 1 divided by 8 plus d cube. So let us divide. So now let us one by one we need to eliminate the terms. So for in such a way that we need to choose quotient. X raised to 4, here first term is 8, so choose quotient as x raised to 4 by 8. So 8 into x raised to 4 by, multiply both to this, so 8 into x raised to 4 by 8 which will be x raised to 4 plus d cube. So d cube of x raised to 4 by 8. So now let us calculate that one, d cube of x raised to 4 by 8. So differentiate once 4x cube, another time it will be 12x square, then third time 24x by 8 which will be 3x. So now 3x, let us subtract this one, x raised to 4, x raised to 4 get cancels. So 2x minus 3x, it will be minus x plus 1. So now choose the quotient again to eliminate first term minus x. So minus x by 8, minus x divided by 8. So plus minus x by 8. So choose multiply 8 plus d cube to minus x by 8 which will be minus x plus d cube, 3 times if you differentiate that will be 0. So now subtract minus of minus plus. So minus x plus x get cancels, 1 we get. So 1 divided by 8, choose quotient as 1 by 8. So 1 by 8 into multiply this 8 plus d cube to 1 by 8, it will be 1. So subtract, it will be 0. So here finally we get pi, which is quotient x raised to 4 by 8 minus x by 8 plus 1 by 8. So this is the pi. So final solution is from 1 y equal to CF plus pi. Write together both the terms, we get final solution of given problem. Let us solve another problem. Solve d square minus 4d plus 4 into y equal to e raised to 2x plus sin x. So this was given in exam June 19 for 6 marks. So if you look at this problem, it has y as well as x. So now it is called non-homogeneous equation. It is non-homogeneous linear differential equation. So if non-homogeneous, we know general solution y equal to CF plus pi. So let us find out CF and pi separately. First find out CF, then later we will go for pi. So for CF, refer LHS. So on our LHS we have d square minus 4d plus 4. So by referring that, we can write auxiliary equation as m square minus 4m plus 4 equal to 0. So if you look at this, it is of the form m minus 2 whole square. So a minus b whole square form. So it means m minus 2 equal to 0, m minus 2 equal to 0. So m values are 2, m equal to 2. So total m values are 2. So for this, CF can be written as C1 plus C2x e raised to 2x. So this is the CF. Then let us go for pi. So pi, we know pi is x term divided by d term, x by f of d. So here in this problem, x term is e raised to 2x plus sin x. So e raised to 2x plus sin x divided by d square minus 4d plus 4. So now here we have numerator two different terms. So it can be written as e raised to 2x by d square minus 4d plus 4 plus sin x by d square minus 4d plus 4. So take this as some equation start. Now these two are different forms. So let us simplify separately. So first let us simplify e raised to 2x divided by d square minus 4d plus 4. So e raised to 2x by d square minus 4d plus 4. So it can be written as e raised to 2x divided by d minus 2 whole square. So now we know the result. If it is e raised to ax by d, then it can be written as e raised to ax by a. So d can be replaced by a. So now here a is 2. So this can be e raised to 2x divided by d replaced by 2. So it will be 2 minus 2 0. So denominator becomes 0, which is a indeterminate form. So now whenever denominator becomes 0, whenever x by f of d, if it takes the form x by 0, so it can be written as x into bracket x by f dash of d. So now, so let us apply this result. So x into e raised to 2x by derivative differentiation of denominator. So d minus 2 whole square for 2 into d minus 2. So now, so here we got this. So again let us apply substitute d by 2. If you replace d by 2, so here we get 2 minus 2 0. So denominator becomes 0. If denominator becomes 0, then we write it as multiply by x and e raised to 2x by differentiate with respect to d. Derivative of d minus 2 is 1. So 2. So total it can be written as x square e raised to 2x by 2. So this is first term. Now let us simplify second term. Sin x by d square minus 4d plus 4. So let us simplify this one. So we know in case of sin ax or cos ax, So we have sin ax by d square is equal to sin ax by minus a square. So whenever we have sin ax or cos ax, denominator d square, replace d square by minus a square. So here sin ax, 1x is there, so 1 is there, a is 1, so a square is 1, minus of 1, so replace d square by minus 1, so sin x divided by, so 4 minus 1, 3 minus 4d we get. So here now we got denominator d, but the result is only for d square. So anyhow you need to convert d to the d square. For that, multiply and divide by d plus 4d. Multiply numerator and denominator by d plus 3 plus 4d. So now if you multiply it, so it can be written as 3 plus 4d into sin x divided by, so a plus b into a minus b, so 9 minus 16 d square. So now replace d square, denominator d square replaced by minus 1, so we get, so minus 16 into minus 1, so plus 16 plus 9, so it will be 25. So it can be written as 1 by 25 into bracket 3 sin x plus 4d sin x, 4 differentiation of sin x cos x. So whatever you got, this is second term. So total from star pi is, so pi has two terms, e raised to 2x by this, e raised to 2x by this term is x square, e raised to 2x by 2 plus, so second term sin term simplification is this 1 by 25 into 3 sin x plus 4 cos x. So this is the final pi. Now final solution, general solution of this, from 1 general solution, y equal to cf plus pi. So cf is this c1 plus c2 x into e raised to 2x plus pi. So pi term is x square e raised to 2x by 2 plus 1 by 25 3 sin x plus 4 cos x. So this is the final answer. Let us solve another problem. Solve d square minus 3d plus 2 into y is equal to 2x square minus sin 2x. So in this problem we have y and x term, so it is non-homogeneous equation, it is non-homogeneous. So if non-homogeneous linear differential equation, solution is y equal to cf plus pi. So in this problem let us find out cf and pi separately. First let us find out cf. For cf refer LHS, which is d square minus 3d plus 2, so where replace d by m, so we get auxiliary equation, that is m square minus 3m plus 2 equal to 0. So now it is a quadratic equation. Find the solution of this or find the m values. So here, so 2 can be factorized as minus 1 minus 2, so product 2 add, it will be minus 3, so it can be written as m minus 1 into m minus 2 equal to 0. So m minus 1 0, m minus 2 0, so m value 1, m value 2, so total m values are 1 and 2. So once you get this, find the nature. These are the real and not equal, 1 is not equal to 2. So in case of distinct roots, cf we write it as c1 e raised to x 1x, c2 e raised to 2x. So this is the cf, half of the solution we got. Then you go for pi. So here we know pi is x term divided by d term. So in this case x term is 2x square plus sin 2x divided by d term. So here d term is d square minus 3d plus 2. So now both are different terms, one is algebraic term, one is trigonometric term. So divide separately, 2x square divided by d square minus 3d plus 2, one term. So then second term sin 2x divided by d square minus 3d plus 2. So separately let us consider equation star. So now let us simplify these two separately. First this one 2x square by this. So now this is a polynomial in x. Here we solve by normal division method. So here 2x square inside the division table, outside the right in ascending order 2 minus 3d plus d square. So now choose quotient such that this term should be eliminated. 2x square by 2, so it is x square. So multiply all terms to x square. So 2 into x square 2x square minus 3d x square, 3 differentiation of x square. So 3 differentiation of x square is 2x. So 3 into 2x is 6x. So this is 6x plus d square of x square, differentiation of differentiate twice, x square differentiation 2x into 2. So it will be 2. So now subtract 2x minus 2x get cancels. This will be minus of minus plus 6x minus 2. 6x minus 2 we got. So now let us choose another quotient. So here 6x has to be eliminated. 6x divided by 2, which will be 3x. So multiply all terms to 3x. 2 into 3x 6x minus 3d into 3x, minus 3d into 3x. So differentiation of 3x is 3. So minus 3 into 3. So it will be minus 9. So minus 9 we get. So d square of 3x is 0. So minus of minus 6x minus 6x get cancels. So minus of minus plus 9 minus 2, 7 we get. So now you have 7 divided by this. Choose quotient 7 by 2. So multiply 2 minus 3d into d square to 7 by 2. So it will be 7. 2 into that 7. Differentiation of that term will be 0. So 7 minus 7 0. Now we got remainder 0. So therefore finally we can conclude that 2x square by d square minus 3d plus 2 is equal to x square plus 3x plus 7 by 2. So this is first term. Let us go for second term. Sin 2x by d square minus 3d plus 2. So here sin 2x. So d square, whenever d square is there, replace by minus a square. Minus a is 2, a square 4, minus 4. So we get sin 2x divided by, so minus 3d. So minus 4 plus 2, which will be minus 2. So minus sign common here. So if you take minus sign common, so sin 2x divided by 3d plus 2 we get. So here, so denominator is d, but whenever sign is there, denominator must be d square, then only it can be simplified. So to convert denominator term to d square, multiply by its conjugate 3d minus 2. Multiply and divide by 3d minus 2. So when you multiply, it can be written as minus 3d minus 2 numerator into sin 2x divided by, so 3d square is 9d square minus a square 4. So now replace d by d square by minus 4. So 9 into minus 4 minus 36 minus 4 minus 40. So numerator is minus sign is there. So minus of minus 40 plus 40. So 1 by 40 into bracket 3d, 3 differentiation of sin 2x. So differentiation of sin is cos 2x into 2. So 3 into 2 cos 2x is 6 cos 2x minus 2 sin 2x. Like this we get. So if you take here, we can take 2 common. So if you take 2 common, it will be 1 by 20 into bracket 3 cos 2x minus sin 2x. We get this. So this is second term. So finally pi. So total pi is, so we can write it as, so pi is first term is x square plus 3x plus 7 by 2, and plus second term sin 2x by this simplified as 1 by 20 into bracket 3 cos 2x minus sin 2x. So this is the final pi. So finally solution can be written as solution from 1 y equal to CF plus pi. So write the terms of CF and pi together. That is the final solution of given problem. Solve d square plus 4 into y equal to x square plus cos 2x, which has been given in the VTU model question paper. So now, here if you look at this problem, it has y term as well as x term. So it is called non-homogeneous linear differential equation. So if non-homogeneous, we write solution y equal to CF plus pi. So take this as equation number 1. Now let us find out CF and pi separately. For CF, refer LHS so, and replace d by m, write the auxiliary equation. So auxiliary equation is m square plus 4 equal to 0. So m square plus 4, m square equal to minus 4, m equal to square root of plus or minus square root of minus 4, which will be plus or minus 2i. So which can be written as 0 plus or minus 2i. So alpha is 0 and beta is 2. So now in case of this, we write CF as e raised to 0x, e raised to alpha x, c1 cos beta x 2x plus c2 sin 2x. But e raised to 0 is 1. So c1 cos 2x plus c2 sin 2x. So this is the CF. So now let us find out pi. So pi is x term divided by d term. We know this. So x term is here RHS, x square plus cos 2x, x square plus cos 2x divided by d term d square plus 4. So now both terms are different. This is a x square is a polynomial in x and this is a trigonometric term. So now separate it. So divide separately, x square divided by d square plus 4, one term. Another term is cos 2x divided by d square plus 4. So take this as equation number some star. So now let us solve separately. X square by d square plus 4. So this is a polynomial x. So we apply normal division method. So here inside the bracket, this term x square, division table, outside this 4 plus d square, 4 plus d square. So now choose quotient. How? In the way that this should be eliminated. So x square by 4, choose x square by 4. So now multiply both to x square by 4. So 4 into x square by 4, x square plus d square of x square by 4. So d square of x square by 4, in the sense differentiate twice. So one should differentiate 2x, another time 2 by 4, which will be 1 by 2. So 1 by 2. Subtract x square minus x square get cancels. So now remaining is minus 1 by 2. So minus 1 by 2, then to eliminate this, divide by 4. Choose quotient as minus 1 by 8. Minus 1 by 8. So multiply 4 into minus 1 by 8, which will be minus 1 by 2, plus differentiation of minus 1 by 8, 0. So subtract minus 1 minus plus. So minus 1 by 2 plus 1 by 2, it will be 0. So the first term, x square division process got completed, and quotient obtained itself is the x square by d square plus 4. So x square by d square plus 4, this is equal to x square by 4 minus 1 by 8, this term. Now let us go for second term. Second term is cos 2x by x d square plus 4. Cos 2x divided by d square plus 4. So now we know in case of cos ax by d square is equal to cos ax by minus a square. So now replace d square by minus a square. So here d square is there. So you replace by minus a square, minus 2 square is 4, 2 square is 4, minus of 4, minus 4 plus 4 0, so it will be 0. So whenever now it becomes cos 2x by 0. So don't write this one because it is indeterminate form. So it can be in case of 0, it can be written as x by f of d. If it takes the form x by 0, then the same thing is equal to x into capital X by f dash of d. So let us apply this result. So x into cos 2x divided by f dash, differentiation of d square plus 4 is 2d. So this is how we get. So now here 2 outside, so if you take outside it will be x by 2, x by 2. So 1 by d is integration, so integration of cos 2x. So integration of cos 2x is sin 2x by 2. So x by 2 into sin 2x by 2. So finally we get x sin 2x by 4. So this is second term. So from star pi, from star pi equal to first term x square by d square plus 4, that is first this term x square by 4 minus 1 by 8 plus second term cos 2x by this, so that itself is x sin 2x by 4. So this is pi, required pi. Now final answer from 1, y equal to cf plus pi. So cf we know, c1 cos 2x plus c2 sin 2x plus pi. So pi is this term x square by 4 minus 1 by 8 plus x sin 2x divided by 4. So this is the final answer.